So find the two positive integer. Let the positive. So because for what sum you must write, it is not that okay you just simply take x and y, that is okay for calculation, but when the what sum is given you must write it. Let the positive numbers be x and y. So then the condition that is given, because here one will be the constraint, means that first you should formulate or you can write the equation, that constant equation rightly. So here constant equation is that summation of these two number x plus y is equals 24. And now that means if x and x plus y is 24, there could be many way that x value could be. It could be 1 plus 23, it could be 2 plus 22. And see, for example, if 24 is broken, to keep this relation correct, we can break 1 plus 23, 2 plus 22, 3 plus 21. That way we can break it. Now you see that what the answer that, see if you multiply these two terms, in this case, for example, if this is the answer, so it is 1 into 23, that is 23, 2 into 22, 44, 3 into 21, 63. See that it is increasing, correct? So that means we don't know that when this will maximum. So for example, this is a smaller sum, maybe you can do here, you can expand it and you can tell that yes, this is the value of x and y for which this product is more. But if this bigger number is given, we cannot solve it. So we should follow the process of calculus will help us to get which value or which value of xy will give us the maximum values. So now second one is a for for the maximum minimum. So what you want to do, maximize or minimize? Okay, that is why, so here they want to maximize the product. So if the product is written as a p, so there this x and y is the product of these two number. Like this product of these two number, we have to find out when is the maximum values we are able to get it. So the process is that, see that p, now it has a two variables, so derivative for two variable will not be able to do here. So what we'll do that here, so we'll utilize this equation here. How is, so if we can do for any parameter here x or y. So generally what we do that, we replace the value of y. So y is 24 minus x. So then we'll replace the value of y here. Okay, once it is done, then let's see that if if we multiply, it will be 24x, and x is x square. So now we have to maximize this product p. So what we'll do that now, differentiating. So this is now p became function of x, and this function you have to maximize. So this became now a easy problem of, first what we'll do, first our step is first to do dy by dx of the equation is a first step. Okay, so this first step is dy dx. So we'll do ddx of p here, and this side we'll do ddx of 24x minus x square. And as we know, the process that ddx or plus or minus minus sign ddx can be applied for each term. So next simplification is we'll use ddx for this, and again ddx of x square. Now 24 is constant, 24 we can keep it, and then ddx of x is 1. Now here ddx of x square is 2x. Okay, so the second step is that for maximum and minimum dy dx will be 0. So we have to write for maximum and minimum dp by dx will be 0. So these are the sentences you must write. So then that means 24 minus 2x is 0. Okay, so from here you can solve the value of x. So if you are not okay, not don't want to this, if you don't want to do this, so this is one way. I'll show you. This is one way. Okay, so here minus is there. So if equal sign is there, division by minus doesn't get any problem. So we will divide by minus 2 both the side. So like minus 2x by minus 2, and here minus 24 by minus 2. If you do this division, then what happens? So that this get cancelled, and what we get here is we get here x equal to 12. Okay, so we got value of x equal to 12, and that's the value where we'll get maximum or minimum. But we don't know till that okay x equal to 12 will give maximum or minimum, because I told that okay there could be up and downs. So dy dx, only dy dx or here dp dx will ensure that yes these are the x equal to 12. Like that meaning is that in this car, say curve is like this or something, but we this is only telling that x equal to 12, you will get some like this. So but this is a maximum or this is a minimum. It could be a 12 also, this could be a minimum also, so that it doesn't guarantee. So to get that to a step, so our third step is d2y by dx square we need to find out, and then it is a greater than 0 or less than 0 we need to find out. For maximum it has to be less than 0. So next process is that means these are this dp by dx was 24 minus 2x. So I'll write again, dp by dx was 24 minus 2x. Now if we do this derivative again, we write d2p by dx square. We are doing derivative again, so we will apply here ddx both the side, this one. So for first term ddx of 24 0 minus 2 is constant 2, ddx of x is 1. So that means this value became minus 2. So what happened here? Here, okay, I'm writing here. You can, if you write down there. So here d2p by dx square, it became minus 2 is less than 0. That means 0. So okay, so uh, so how to write that so for x equal to 12, x equal to 12, 12, x equal to 12, p will be maximum. Why? Because d2p by dx square is 0. So you have to write that for x equal to 12, 12 this function p function, because always remember we are trying to uh, maximize this p function. So when you are talking that for x equal to 12 we got it. So a step is that in a dy dx you will get x values or y values. So that values okay, for that values we have to test it. But here what happens is that d2p by dx square there is a no x star, it become directly -2. So it is a directly you are taking decision without putting values of x here, because x term is not there, so it became less than 0. So for x equal to 12 this will be a p will be maximum. Okay, so but p, yes, so what is that maximum values also we need to find out sometimes. Okay, it will be maximum. So we need to find out. So now what we'll do that for it. So maximum value of p. What is that p max values? So take the equation 24x minus x square. So put the value of x equal to 12. This x equal to 12. So 24 into 12 minus x square is 12 square. 12 square. Okay. So from here you will get the values. So basically you will get 12 into 12 here. So that is a 144. So this is the way you have to find the. So this is the calculation, you got it here, 144. So as we summarize that, so from constraint equation, from the, okay, let us go from the beginning. From the constraint equation x plus y equal 24 was given. From there you isolate y, okay, and then you put which function. So before this step what you have to do that, first step is that your constant equation, then isolate x or y, okay, then isolate x or y, okay, then third means the first step itself, constant equation, isolate x and y, and then find max function, max or minimum function, for which you have to do maximum minimum function, okay, and there you, then the third step is the replace x or y there, x or y, okay. So let's see that what we have done. So this is a constant function. In a constant function we have isolated y, then this is the max, the function we need to maximize it, there you replace that y and it comes like this, okay, and then we have to do the first derivative of that with respect to variable. In this case this is x, if it is a y we have to do d by dy. So after doing this, so you will come to a equation, this equation. Now our uh, next step is that we have to make dy dx as a 0. So because as we have explained that for up and downs, those are the places dy dx becomes 0. So mm, so this dp by dx here you have to make 0. So we made dp by dx 0 here, and we got x value equal to 12. This is your algebraic solution part. I have already explained earlier. So x equal to 12. Once x equal to 12, so we have to see that for x equal to 12, what is a double derivative. So we have done the double derivative and we got directly minus 2. We didn't put x equal because there is no x now. Automatically, in this function it became negative. So if it is a negative, that means for x equal to 12 we will get a positive value, or sorry, it is a maximum value we will get it. So for, okay, so, and what is the maximum value? To get the maximum value, always you take the function and you replace the value of x there, and we got the 144 here after replacing. Okay, so that after replacing we got the 144. So here, so okay, this is the total process. Okay, so again I'll repeat that what we are doing from beginning is that we write a constant equation, uh, isolate isolate y from there, then you write this is the maximum function for which we are trying to maximize it, replace it. Okay, then you get the equation, you simplify the equation, then you do this first derivative, that first derivative you make it 0, from there you find x values, then you do the second derivative and you have to take decision. If the x is there, you have to put this value of x here. Okay, and in this case it is minus 2, so we didn't put it here. So after this you take the decision about the sign of double derivative. If it is a less than 0, so that for x equal to l you will get the maximum, and then you replace the value of x to get the maximum values. So this is the way you have to do this maximum value of problem.